Hello everyone, in this video I'm going to introduce how to work with definite integrals. So remember, previously we learned about indefinite integrals. So integral of x dx is equal to x squared over 2 plus c. So what kind of form we have here? So we have integral of a function. So that is equals to antiderivative of that function plus a constant c. So by convention, this capital Fx that represents the antiderivative. So now if we have integral of x dx is equal to x squared over 2 plus c. So if we compare, so we say that antiderivative in this case is x squared over 2. And if we now we have a function that we can evaluate at different values. For example, if we want to write the value of f of 5, so f of 5 would be 5 square over 2 plus some constant. Similarly, if you want to find f of 3, so input is 3, so that would be square of the input, so 3 square over 2 plus c. So in this case, c is what? It's the same constant. And now if you want to find the change in the value or change in the y value, so that would be f5 minus f3, so that would be 25 over 2 plus c minus, and then we have f3 9 over 2 plus c. And when you open the bracket, c and c gonna get cancelled. You get 25 over 2 minus 9 over 2, which is 16 over 2, which is 8. So what does this 8 represent? So 8 units is basically the area under this curve from x equals to 3 to x equals to 5. So based on our previous example, we can say that integral of fx dx from a to b is equal to fb minus fa, where a is the lower limit, which is smaller of the two values, and b is the upper limit, of course, which is the larger value. And then fb minus fa. So what is fb? So fb is the antiderivative evaluated at the upper limit. fb is the antiderivative evaluated at upper limit, and fa is the antiderivative evaluated at lower limit. And previously we did this example, so we figured out that integral x dx from 3 to 5 is f5 minus f3, which is 8. So what this definite integral gives us, so it basically gives us area under a function. So let's say we have this graph where we have a function fx, and we want to figure out the area between two limits from a to b. So that area would be given by definite integral from a to b dx. So in order to solve the definite integrals, we're gonna use the same integration rules that we learned earlier, but just we're gonna do one more step in the end. We're gonna plug in the values of integrals in the end of the problem. Before we jump on to the examples of definite integral, just a quick recap of integration rules. So integral of a constant is kx plus c. So the power rule is, so you increase the power by 1 divided by the new power plus c. But if you have another variable in place of x, so integral of u raised to power n du, again same thing, you increase the power of the function by 1 divide by the new power plus c. So here our u is a function. So this is our substitution rule that we learned. Then we learned that if the power, so again here power should not be -1. But if the power is -1, so we have our ln rule. So it means this should be ln of absolute value of u plus c. So this is our substitution again. So this is our logarithmic form. And then last one we have integral of e raised to power u du. So u is a function of x. So if you have something like e raised to power a function and differential of the function, so that integral is e raised to power that function plus c. So this is our exponential form. So this is just a quick review of what we have learned about integrals so far. So let's do some definite integrals problems. Find the integral of x squared dx from 1 to 2. So basically what we are going to figure out, so we have a parabola x squared which looks something like this, and we want to find area under the curve from x equals to 1 to x equals to 2. So basically we are interested in this area. So that is our y is equal to x squared. All right, so in order to find the definite integrals, so first we find the integral. So integral of this should be x cube over 3 plus c. But in case of definite integral, we don't put c because we're going to do upper limit minus lower limit. Then our c going to get cancelled. So we simply write x cube over 3 from, so values should be from 1 to 2. And then we plug in the values. So first we're going to plug in our upper limit. So that will give us 2 cube over 3, and then we gonna plug in our lower limit, so that will give us minus 1 cube over 3. So we get 8 over 3 minus 1 over 3, 7 over 3. So this area is 7 over 3 units. So we figured out area under the curve from x equals to 1 to x equals to 2. So we always get the area above the x-axis and below the curve. All right, let's take a look at next example. So we need to figure out this integral from 0 to 3. Again, integral of 4x cubed. So x cubed x4 over 4 minus 2 times integral of x is going to be x squared over 2 plus 2 integral of 2 is going to be 2x. And we're going to have limits from 0 to 3. So first we're going to simplify it further. So 4 and 4 cancel. So we get x4 minus x squared plus 2x. So limits of integration from 0 to 3. And now let's plug in the values. So upper limit in the function, so 3, 4 minus 3 raised to power 2 plus 2 times 3. So upper limit minus lower limit. So substitute the lower limit here, and in the end we get, so we notice that this guy is just 0 because all the terms here are 0. So for the other one we get 78 upon our calculations. So that's how we evaluate this definite integrals. All right, so in the next one, so integral of e raised to power x, we know that integral of e raised to power x is just e raised to power x. But then we have the limits of integration from 0 to 2. So we plug in the value. So upper limit minus lower limit. So e raised to power 0. So this guy is 1. So it means we get e raised to power 2 minus 1. And if you want to convert this in decimal form, so this is about 6.39. So in this one, we have integral from 1 to 5, 3 over x. So 3 I can take out. So I can write this as 1 over x dx. So integral of 1 over x dx is ln x. So that is natural ln of mod x, right? So ln mod x. And limits of integration from 1 to 5. And since our x is just positive here, so limits of integration are positive. So we can remove the mod sign. So we get 3 ln 5 minus 3 ln 1. So ln 1 is just 0. So this fella becomes 0. So we just get 3 ln 5, and in decimal form you get 4.9. 8, 3. So that's how we compute our definite integral. We just do one extra step in the end. So if we talk about the comparison between indefinite and definite integrals, so there are few differences. So first difference is in terms of notation. So in case of indefinite integral, we just have this integral sign fx dx. And in case of definite integrals, we have the limits of integration. But they both use the same rules of integration. So when we write the result of an indefinite integral, so we write this in the form antiderivative plus constant. So in case of definite integral, we don't write any constant. We just do antiderivative in the upper limit minus antiderivative on the value of antiderivative on the lower limit. So we just evaluate the values at upper limit minus the value at lower limit. And in case of indefinite integral, the result is a function. In case of definite integral, the result is a number. A number. So if we ask the question that what is the definite integral good for? So I can show you like what it is good for. We already talked about this a little bit. It is related to the areas. So let's take a look at this example. So integral of x dx from 3 to 5. So when we did this integral previously in this video, so we found that this integral is equals to, the value of this integral is equals to 8. So we figured out that this is x squared over 2, and then you put the limits of integration. So 5 squared over 2 minus 3 squared over 2. So that is 25 over 2 minus 9 over 2, which is 16 over 2. And in the end, we got 8. So we already found that integral from 3 to 5x dx equals to 8. But what does this mean? So let's try to graph our function x. So this is our function y is equal to x or fx equals to x. And then what we're going to do is we're going to figure out the area under the curve between 3 to 5. So we are interested in this area. So if we try to figure out this area, so when x is 3, so this is our f3, which is 3. When x equals to 5, this is our f5, so value of the function is 5. The height of the function is 5 at this point. And if you want to figure out this area, so I'm just gonna, so we are interested in this area. So if you want to find this area, you can split it into two parts. So area of the triangle plus area of this rectangle. So area of rectangle would be, so between the so this length is 2 and this height is 3. So that would be 2 times 3. Similarly, area of triangle would be half times base. So base is again 2 and height is, so height is the difference between 5 and 3. So this height is 2. So times 2. So what we get? So 6 plus, so 2 and 2 cancel, so plus 2. So we get 8 square units. So we got area, this shaded area is 8 square units, and also the value of integral is 8. So they are same. So integration allows us to find the areas. And if we have a complicated looking graph where we cannot find area by using our geometric methods, so then we can use integration to find this area. So integration allows us to find areas of complicated functions. So that's what the definite integral is good for. I hope that makes sense. If you like this video, please hit the like button and I'll see you next time. Bye for now.